Okay, so we're going to be doing 4.2, numbers 16 and 18. And the directions are use the given root to find the remaining roots, then find an equivalent form of the function. So they want you to find the roots and then write it in factored form. That's all they're saying. So if you look at what we did here, so what happened here is they gave us a function and then they gave us a root at 8. So the very first thing we did was we wrote its factor, right? So if x equals to 8 is the root, then his factor is x minus 8. So then we took x minus 8 and we took them over here and we used a long division to find kind of like if this is a factor, what's his partner, right? So if we take 16 divided by 6, who's 6's partner? It's 10. So now we have this quadratic. And then we just factored that quadratic and we got x minus 3 and x minus 3. So our factored form is going to be x minus 3 times x minus 8, right? And our zeros are x is equal to 8, x is equal to 3, and x is equal to 3. So you're basically using the 0 to find the rest of the zeros, okay? Now, I'm going to be honest with you. With this one right here, if they did not give you x equals to 0 is the root, you should have already known that. What here tells you that that 0 is like, what do you notice about this? I'll just ask that way. What do you notice about this function? Maybe it's a little too tiny. What do you notice about this function right here? Anybody? Does anybody see anything? What do you notice? I'll read it. 6x cubed minus 18x squared minus 60x. There's a couple of things that I want you to notice. There's something very obvious that I want you to be like, oh, Ms. Johnson, I noticed this. Does anybody see that? Yes. Sorry, someone said this. Yeah, I don't know. I can't see everybody's chat. This is so weird. So yeah, they are all multiples of 6 and they all have an x in it. So because they all have a 6 and an x, that's the first thing that I'm going to do. I'm going to ignore the fact that this has a root of 0 because I found something else that I can start with. So I'm going to start there. So I get 6x cubed minus 18x squared minus 60x, right? And so the very first thing I'm going to do is I'm going to factor out the greatest common factor, which in this case happens to be 6x, right? So I'm going to take out 6x. And so your task right now, if you're following along with me, is to figure out what goes in here. So you're playing who's missing, right? So you're going 6x times what? It gives me 6x cubed. 6x times what gives me 6x cubed. I'll give you a couple seconds to do that. Then do 6x times what gives me negative 18x squared. 6x times what gives me negative 18x squared. And then 6x times what gives me negative 60x. Yeah, you guys are giving me some pretty good answers in the chat there. So I'll just fill this in. So 6x times x squared gives me 6x cubed, right? 6x times x squared. 6x times negative 3x gives me negative 18x squared. And 6x times what gives me negative 60x squared? Well, that's just minus 10. Okay, and I'm going to set this equal to 0 because they're telling me to find the roots, which means it has to equal to 0, right? So then if you look, I didn't even need the fact that x was a root. It actually told you because there's an x in every single one, right? My very first strategy whenever I'm dealing with like this kind of stuff is always going to be factor out the greatest common factor. Okay, so in case you don't know, this thing and this thing are equal, right? These two things are equivalent expressions. this is like a $20 bill, pretend, and this is two $10 bills. Okay, they're equivalent. They look different, but they're equivalent. They have the same value. Okay, so the next thing that I'm going to do is I'm going to try to factor this thing. And you guys all know Miss Johnson, she likes to factor. So the 6x stays, and then I'm thinking of what two things multiply to get to -10, but add to get to -3. What two things multiply to get to -10, but add to get to -3. So we get x minus 5, x plus 2. If you need some review on factoring, there's a couple really good videos that we made last semester about factoring. There's a bunch of really good videos out there in general. Just you know, search out YouTube for factoring. My suggestion is I use this box method. I like it because it's very concrete. It gives me a first step, a second step, a third step. I won't necessarily use it every single time, but it's there. Okay, once I have these three factors and I can't factor anything out of any of the pieces, nothing here, nothing here, nothing here, then I use the zero product property. The zero product property says, and this is why you like zero so much as a, you know, as when you were learning your multiplication tables, is whatever times zero always gives me zero. So then I say, okay, then u equal to 0, u equal to 0, and u equal to 0. So I just write that out. And I say 6x, oops. 6x equals to 0, x minus 5 equals to 0, and x plus 2 equals to 0. Therefore, x is equal to 0, 5, and -2. So 6x equals to 0. Wow, this is really catching up slow here. So 6x equals to 0. This piece, x minus 5 equals to 0, x plus 2 equals to 0. There's my zeros. So did I find, so the first thing it says is find the rest of the roots. I did that. Now I should be looking for 3 roots because the fundamental theorem of algebra says that if I have a cubic, meaning that's the highest exponent that I have, so the degree is 3. If I have a cubic, then I should be looking for 3 answers. Look, I found 3 answers, right? Yay, me, right? The second thing it says, then write an equivalent form of the function. So because these are my zeros, that implies that my roots, right, are like that as well. So I already did that. That's this right here. So I already did both of those answers. So I'll highlight them so you can find them. So here is my equivalent, and here are my zeros, right, for this one here, right? So this here, this line here, this line here, okay? And I'm just gonna scoot this over just so I can get a clean number 18, so it's not in the way at all. So that's this is your number 16. Any questions on number 16? Any questions on number 16? What was the hardest part? What's the part that you're going to get confused on? How did I get this 5? This 5 here? Oh, so if I solve this, right? If x minus 5 equals to 0, can you all agree with me that I would add 5 to both sides? So then I get x is equal to 5. Yeah. Very good. Yeah. Okay. How did I get this one? Oh, okay. I just factored out the greatest common factor. So the first question I asked you guys was, what do you notice? And you guys all said, or some people said, I noticed there's a 6 in every single, like you can factor, right? Right. So then you factored out 6x, and this is what's left. So 6x times x squared is 6x cubed. And then 6x times -3x is -18x squared. And 6x times -10 is -60x, right? So then how did I get this one? Was I just factored, x squared minus 3x minus 10. And so the way you factor is it's kind of like this thing, right? If you don't remember how to factor, it's not that big of a deal, but it will be a big deal, you know, in the next 3 sections that we go over. So make sure that the next 3 lessons that we go over. So make sure you go in and you go look for my factoring videos. It's not that hard. You just have to get used to thinking like what 2 numbers multiply to get to -10, but add to get to -3. and that happens to be -5 and 2. So here it's what two numbers multiply to get to 9, but add to get to -6, and that's -3 and -3, right? Very good. Okay, I figured out how to fix my chat. Is if I close it, it'll alert me if you guys chat new. I assume, because Sam, I can't get any of your chats for sure. So now I'm going to try this one. Now this one's a little bit different, right? And I'll tell you, well, you tell me, why is this one different? Why is this one going to be different? What do you see as the difference of this one? Yeah. One of the main differences that I see is my root is an I. Okay. My root is an I. So walk down this path with me really quick. What is I? What is I? No, I is not -1. I actually is the square root of -1. Yeah. So I is the square root of -1. What does Miss Johnson tell you about square roots? Okay, sounds good. What does Miss Johnson say about square roots? Anybody remember this? Yeah, there's two answers. So you're telling me that if I have a 2i, there is an I that's missing. Yes. Just like your eyes, they travel in pairs, right? So i's travel in pairs. Square roots, they travel in pairs. So if I have a 2i, I'm going to tell you right now, his partner is what? What is his partner that they didn't tell you, but they kind of told you? Yeah, it's -2i. So the very first zero that I find is x equal -2i. Now let's say, Ms. Johnson, wait, what? Where'd you get that from? Okay, so one more time. I is the square root of -1. What have I always told you about square roots in terms of when you're solving an equation? Always put a plus or minus. So if you have the positive version, it means the negative version is right there next to you, right? Okay, yes, exactly. So here's one of my zeros off the bat, just because i's and square roots travel in pairs. If it's a root, right? If they say, hey, this is a root and it's an I, just already say, okay, his partner is essentially his partner is the conjugate of him, but in this case, it's just the opposite of him. I'll explain more later on. Okay. So for now, all you need to know is it's here's your second one. Now, how many am I supposed to look for altogether? How many am I supposed to look for altogether? How many am I supposed to look for altogether? Yeah, I should be looking for 3 roots. And you're like, Miss Johnson, I already found 2, right? So all you have to do is find one more. Yes. So I will find the third one based on these 2. Okay, so let's practice. If I know that x equals to 2i is my root and x equals -2i is my root, what are their factors? If x equals to 2i is my root, then what is its factor? It's still the same, I promise. So here we said, let's see, 5 is the root, x minus 5 was the factor. -2 was the root, x plus 2 is the factor. X is equal to 8 is the root, x minus 8 is the factor. You guys all see that pattern? Very good. So this factor is going to be x minus 2i. Everybody okay with that? What is his factor going to be? What is his factor going to be? Very good. Yep. X plus 2i. Okay. Now, some of you are saying, hey, Ms. Johnson, this is different. The way you're doing this problem is a little bit different. Before you got the factor and you started doing long division. Now, you can do long division on this, okay? But it's going to get really messy with my i's and my x's. I'll show you just so you can see. But let me finish this thought. Anybody have any suggestions on what I could do right here? What is this? What is this telling me to do? Right here. What is this telling me to do? Yeah, it's telling me to multiply. So let me multiply really quick. So Ms. Johnson, you want me to multiply? So I'm going to multiply this over here using my box because the box is my favorite. Oh, Desmos. Desmos is also my favorite. Okay, so follow me here, okay? Because this is, if you think that this is messy with the x's and the i's, imagine you using long division with the x's and the i's. So what's x times x? Very good, x squared. What's x times 2i? What's x times 2i? Yeah, it doesn't matter. I say 2xi. You could have said 2ix. I don't care. Okay. What about this one? Negative 2i times x. Negative 2i times x. Yep. Negative 2ix. Sure. You could have written negative 2xi. It doesn't matter. Okay, let's do this slowly. What's a negative times a positive? Good. What's 2 times 2? Good. What's I times I? Good. What is I squared? Again, if I equals to the square root of -1, therefore I squared equals to -1. I'm going to say that again. If I equals to the square root of -1, if I squared it, it would be -1. So in reality, -4 times -1, so this is really here, let's put this in this color, -4 times -1 equals to 4. So this is true. Okay, anybody see anything else that happens here? Yeah, 2xi minus 2ix, those are the same. So that's a 0. So in reality, you just have x squared plus 4. And if you think about that, that totally makes sense why your root is 2i and -2i. If you think about why x squared plus 4 is my polynomial, it makes sense because that would yield those two roots. Okay. So now you're thinking, okay, Ms. Johnson, I'm still looking for my third root. Good. So what can I do if I know that this is a factor, right? Because this is a factor, and this is my polynomial. What could I do? Yeah, I could just divide. So now I'm going to do long division on this. Ms. Johnson, it looks weird because you're going to divide by an x squared. I know it's going to look weird, but it's going to act exactly the same, right? So x squared plus 4, I'm going to divide that into x cubed minus 5x squared plus 4x minus 20. There is one more thing that I wanted you to notice here. Does anybody else notice one more thing here? Does anybody else notice anything else here that's different? Anybody notice anything? It looks kind of, if you kind of look at this group of stuff and this group of stuff, you kind of see it. I'm just trying to train your eyes to see things, because if you start seeing these patterns, then it makes your world a little bit easier. Does anybody see it? Here and here. No? Let me see. Hold on. Let me close my chat. Okay, so what I see, and I want you to start seeing it, is whenever I have 4 terms, 1, 2, 3, 4 terms, sometimes I can factor by grouping. And grouping looks like this. Okay, so just pause on this thing really quick. Factor by grouping, you guys already know how to do it. I'm gonna draw it and you're gonna really like, oh, that's factor by grouping, Ms. Johnson? Yeah. This is factor by grouping. You're like the box, Ms. Johnson? Yeah, just take each of these and put them in there. See what happens. X cubed minus 5x squared, 4x minus 20. Okay, so what do you see? What's the biggest thing you could take out of both of these? What's the greatest common factor between x cubed and negative 5x squared? Yeah, x squared. Very good. Now place who is missing. X squared times what gives me x cubed? X. X squared times what gives me negative 5x squared? Minus 5. X times what gives me 4x? 4. Is 4 times negative 5 really negative 20? And you guys are like, yeah. Hey, does this guy right here, does he look familiar? Does this guy look familiar? Have you seen this guy before? Yeah, he's right here. That's that guy. Same. And so right now, when I divide it out, it's going to become x minus 5. No big surprise, right? Hey, Ms. Johnson, why didn't you just do that in the beginning? Because most people don't see this. When you're first starting to factor, or when you're remembering how to factor from like a year ago, most people don't see this. I want you to start looking for things that make your life easier. Because look at, I'm pretty much done right here. And look at all this work that I did. Versus this, I had to do this and this and this and this and this and this. See, all of that. Okay, so let me finish off. Going back over here. So let's see. X squared times what gives me x cubed? You guys will say x. Very good. So x times x cubed. So that's x cubed. Let's see. X times 4 is 4x. I'm going to put that here. And then I'm going to, oh, it's not catching up to me. Hold on. Uh-oh, I made it go too fast. Wow, it's really not going, huh? There it goes. So I'm going to leave this space here because I skipped a space as well. So I'm going to skip that space, right? And then of course I'm going to subtract. And if you know Ms. Johnson, she is going to add the opposite. So if you notice, these two cancel and these two cancel, and then I'm left with negative 5x minus 20. What did I feel like I missed something. Oh, 5x squared, Ms. Johnson, sorry. I forgot to write squared. So x squared times what gives me negative 5x squared, and you're like, oh, that's minus 5. And so I write minus 5x squared. Negative 5 times 4 is negative 20. And of course, I'm going to subtract, but subtracting to me means adding everybody's opposite. And so these are zeros. And you know that wasn't a surprise, right? You should have gotten a 0 here because we knew that this was a factor, right? This should be 0 because this is a factor. So here's my other factor, x minus 5. Does he look familiar? Everyone's like, oh, Ms. Johnson. Yeah, that looks familiar. So which way did you like better? Obviously, most of you are going to choose this way, but it does take some recognition in the very beginning to notice that this has a multiple of 4. Do you guys all see the 4 and the 4? And it's x minus 5. Thank you. X minus 5. You guys all see that? So if you saw it, great. If you didn't, no problem, because look, we got the answer. Okay. So I need to write the factors. Now, sometimes I'm going to be honest with you. Sometimes the answer is going to be, oops, let me go here. Sometimes the answer is going to be this guy in pink. And sometimes it's going to be this guy in yellow. Ms. Johnson, when is it going to be pink and when is it going to be yellow? Well, if I say that I don't want any of my coefficients to be complex numbers, where do you see complex numbers in here? Where do you see complex numbers? Yeah, that pink stuff, right? All those I's. So if I tell you here, write an equivalent expression, and like this one here, it says, write an write an equivalent form of the function, either one of these would be correct, right? But if I restrict it and I say only using real coefficients, I can't use pink because there's a bunch of I's in it, right? So let me review with you really quickly. So here's I's. I's, you should know, always travel in pairs, just like your I's, right? Once I have one, I find the conjugate of the other. Once I have the factors, then I multiply out and then I get one of the factors and then divide out to get the other factor. Sometimes you guys are fancy enough to recognize this pattern here, and then it makes your work a lot shorter because you recognize this pattern. Now, looking at this one right here, do you see a similar pattern? Like basically, does 57 and 72 have a common factor? And the answer is yeah, it's a 3, but that doesn't help you. You're like, hey, Ms. Johnson, is that 3, that 3? Not really. So it doesn't work every single time you have 4 terms, but it does if you notice the pattern. Do you guys all see the pattern? Look at this right now. Do you see the pattern now that you see it? Now that I told you the pattern is there, do you see it now? Yeah, right. So some of you are like, no, I still don't see it. No problem. Here you go. So Ms. Johnson, but I want to see the pattern. I can't force you to see the pattern. What I can do is show you different types of patterns that are really popular and then have you look for those types of patterns. Really good job.